this is our function. It's a piecewise function, and when we get this ready for the integral, we're going to have to break the integral up into two pieces. So let's do that. Our Laplace transform of this function is going to be an integral, and let me generically copy the integral first. And then now, realizing that this is a piecewise function, this has a certain function for going to 1, from 0 to 1. And I don't need to write this, but I'll write it down anyways, because this is going to be equal to 0. But when we integrate from 1 to infinity, that's the rest of them, we would get the e to the minus st times 0, which would make this disappear. Now, this is not an indefinite integral where the indefinite integral of 0 is a constant. This is an actual definite integral. It's improper, but it's still a definite integral, so that's going to be 0. So we really only have to worry about this. And so let's get this set up. And we're integrating with respect to t, so s is a constant, negative 1 over s e to the st. And here we're letting t go from 0 to 1. So let's see what happens when we put 0 in for t, or 1 in for t first. We're going to get e to the s divided by s negative. And then the power should be negative 2, yes. And then put 0 in there, everything disappears, e to the 0 power is 1, so that's just 1 over s. And so all in all, it becomes 1 over s. Let me just switch the order. It's just going to be 1 over s minus e to the negative s over s. Okay? Now, this is for piecewise functions. We have a bunch of other functions that we could deal with, and it turns out that we have Laplace transforms for some basic functions. Constant function, we saw that already. T to the n is a little bit more complicated. If you do t squared, t cubed separately, you can kind of see a partial integration by parts process happening here. And so I encourage you to try it yourselves or look through a video. Oh, that video had it, right? The video that you guys should have watched. We have sine, cosine, and exponential functions, and then we also have the hyperbolic functions, which we probably won't use too much in this class, but real life situations come up with these things a lot. So there's the there's a transform for each of these things. So let's take a quick picture of this and have it in our notes. Now, going into the Laplace world is this integral, and if you have these functions identified already, maybe you can just skip the integral and use this table. And to come back to the real world from the Laplace world, we're going to want to do the opposite thing. And so there is a formula for that, but generally we want to rely on the tables to bring us back. But let's take a look at the formula. Let's see if I have the formula. Maybe there is no formula. There's a formula. I just don't know what it is. But anyways, the idea is you want to be able to come back. And so we'll use the inverse notation, the negative 1 power notation, to be able to come back. And essentially, this set of equations here, or this table, is pretty much this table going backwards. So it's kind of like your derivative and integral list. And they're inverse processes of each other, so we want to be able to go back and forth. I don't know. Maybe they don't even talk about it because they just expect you to use this table to go back to the real world. Now, there's still one important piece to this puzzle. Since we are dealing with differential equations, we're going to need to know how derivatives work. And we'll talk about that next time. But for now, I want us to just practice going to the Laplace world. And then what I have is I actually have a worksheet for you to work that out, to practice doing these things. And then we'll try to practice coming back. So I'll give you about half an hour to work on a worksheet where you're just finding the integrals to go to the Laplace world. And then we'll try to gather ourselves and then do some examples to come back to the real world from S world to the T world. Okay, pause this.